delay. Welcome all. So here's the funny thing. We have this speaker, but someone borrowed it and they broke the microphone. So you guys will just have to tolerate me. Welcome everybody to our 2022 robot reveal. And we are going to reveal the video. We're going to reveal the robot that you guys asked us to build 6 short weeks ago. I think it was actually 7 weeks ago. I think we stole an extra week, but we didn't need it. The robot was technically done on time. So before we do that, we have some awards and recognitions to do. I know you guys are all here to see the robot, but before we do that, we're going to give out some awards. And I need to remind you all about our Pi Day fundraiser through Mod Pizza. So 3.14, go to Mod Pizza, get Mod Pizza, and some of the proceeds will go to the team. We'd really appreciate your support, and you guys get good pizza. So everybody.
Take a flyer in.
What? Oh, and there's flyers up there, so you guys can take a flyer when you're done. All right. So, first recognition is you guys, the community and our sponsors. We want to thank you guys for all of your support and our team. So here's the deal. Building robots is expensive. We spend a lot of money every year, especially on things like hotel rooms and travel, and robot parts, some of which make it onto the robot. We want to say thank you because we would not be able to do any of this without you guys, the community, and your support. Fact of the matter is, this team not too long ago was 5 scrappy kids working out of a science classroom. And even after the pandemic, we are still 20-some-odd kids strong, and we are still going out to the community and doing great things. So that is all thanks to you guys in the community supporting us and supplying us with children, because we use them to make robots. So thank you. Thank you guys. Okay, so some more awards to give out. The first one is we ran a community service competition, and we would like to recognize the group that won our community service competition. So what we did is we gamified giving, and we invited the community to give, and we invited the school to do projects giving out to the community, and it worked. We got people in the community to go out and do service in the hopes of, well, doing good things and winning a prize from us. So the prize goes to Skills USA and the Guild, and I believe there's a representative. So that'll never go away. So thank you. Oh, turn around so that you guys can get your picture taken. Thank you so much for submitting. And our board can't wait to hear what you guys would like to do with your prize. All right. So next up, we have our chairman's presentation. So we have a chairman's team, and the chairman's team is going to be presenting at our competition on Saturday. And so they are going to come up and give their presentation to all of you in the community. Now you guys come on up.
We're Team 2980, and I'm Aljan Torres, a sophomore.
I'm Connor Banton, I'm also a sophomore.
I'm Aristine G, and I'm a sophomore. We are a student-led team that does various service projects and special events to support the community. And the support that we provide the community will hope that they'll support us in our future ventures. When it comes to building our robot is really just a fundraiser so we can continue to support the community.
We do a variety of service projects for our community. One of those projects included an animatronic deer we named Bill. We worked together with the Washington Department of Fish and Wildlife to create an animatronic deer to help catch poachers and make our community a safer place. A request we regularly get through the community is to help make prosthetics for those that have lost the use of some of their limbs. These prosthetics can help people do things that include hands that do woodworking, weightlifting, and even a hand that helped a little girl ride her bike again. Recently, we began helping a little girl named JoJo. JoJo had a tricycle that was motorized, but due to a disease, she has lost the ability to control it herself. As a team, we have worked together to make the tricycle remote controlled to give her parents the ability to help JoJo enjoy the tricycle a couple more times. Another request we get through the community often is to do wheelchair ramps. These wheelchair ramps help people access their homes where they previously couldn't. Currently, we have made 6 ADA compliant wheelchair ramps. The cool thing with these wheelchair ramps is that they are portable, so we can move them around and provide more people of our community with access to their homes once again.
As part of our service philosophy, we're constantly making an effort to better our community, especially those without a steady shelter. In 2018, we did this by making marker homes for our homeless population. This year, those homes were moved to help 2 people get back on their feet. In 2018, we also began our annual blanket drive. Our blanket drive is an annual event where we collect both new and gently used blankets for our local homeless population. These boxes are spread throughout our community and school. In 2020, when the pandemic hit, we also helped to better support our community by producing 1,000 masks for our local grocery stores, retirement homes, and homeless population.
A service we're starting to provide to our first community is menstrual equity awareness. We first became aware of this issue by Team 1868 Space Cookies when they reached out to us asking if we'd be willing to be menstrual equity ambassadors. At our competitions this season, we are going to provide boxes with menstrual products and other supplies to all the different teams to alleviate any extra stress women might have when it comes to their periods. We're also going to be posting flyers to allow other teams to become more aware of the issue. In doing this, we hope that more women will join STEM due to there being less stigma surrounding their periods.
One of our ongoing efforts is helping to make our community more green and sustainable. This idea all started in the 2015-2016 year FLL game Trash Trek when one of our elementary schools began composting waste from their cafeteria. In 2018, we helped them build a garden shed to store their tools that they use to garden. With this shed, they expanded their gardening efforts. The following year, 2019, we helped construct an outdoor learning kiosk for the school to provide the students a place to learn about going green and having sustainable ways. All of these efforts have inspired the other schools in our district to go green and have helped the district win the title of Green Ribbon School District. Going green is an ongoing part of our community and team. As recently as 2021, we made raised garden beds to allow more people of our community to participate in green activities.
Pre-COVID, we had 11 FLL teams within our district. When COVID hit, we were only able to have one FLL team that met virtually due to safety protocol. This year, we have been trying to get our numbers back up, and we have currently 7 active FLL groups within our district. Since 2012, we have hosted Lego camps for young kids. Within these Lego camps, we give them the opportunity to try out mini games where they have to use STEM building skills and work together. Within these, while hosting these events, we hope to allow these kids to explore STEM and FIRST, and also hopefully encourage them or interest them into pursuing a career within these fields. Another way we help our FLL teams is through our Jamboree. Our Jamboree is when our team helps to mentor FLL groups and make sure that they are prepared for their competitions. Our goal as a team is to ensure that everyone has the opportunity to explore FIRST. One way we're working towards this goal is by working with our para-educators at our high school, as well as our special education teachers, to creating an event where we allow those kids with disabilities to really get to explore STEM and FIRST to the extent of what their abilities allow them to. Another way we've worked towards this goal was in 2020, when we sent several members of our team to Costa Rica and to help start off an FLL team there. With the establishment of this team, we have been able to get their community to explore STEM and FIRST for themselves.
Everywhere we go, we like to spread the values of FIRST and show how you can make a difference within your community. In 2019, we did this with our World's presentation at the FIRST World Championships, Changing the World Through FIRST, where we talked about how you can lead by example in your own community. We also presented this at District Champs and at a district event. If you start to show how you can make a difference, you will start a chain reaction that will cause others to follow. In 2020, we created a TED Talk called Use Your Skills for Good. And even through COVID, we were still trying to spread the values of FIRST. Our TED Talk basically allowed others to show how you can just go and try to reach out and help out any way you can, even through the hardest of times. In 2021, ASB, a club at our high school, hosted the Washington State Leadership Conference, and we were asked to host a breakout room. Our topic was on community service and how you can reach out and help out others in any way you can. This leadership conference helped to inspire us to start what we called the Community Service Challenge. The Community Service Challenge encouraged others in our district to reach out and tell us about it. We offered a reward which was used as an incentive to encourage more participation in the challenge. By telling our community about our service, we hope to inspire others to take action and help out in any way they can.
So while we don't always build the best robot, we do build good people, and we provide them with the skills to help them all better their communities. We thank you for your time.
Okay, so I believe that is the first time they've run through that entire thing without their scripts.
It is.
So awesome work, you guys, and they have until Friday to brush that up and present it to the judges. So thank you guys. Thank you very much. Okay, so we want to recognize some of the students for all of their hard work, and we can't recognize all of them. Some of them will be recognized later on, but we'd like to take a minute to recognize a couple. So one of these kids has just been the most wonderful person to have in the robotics classroom. Working with this kid, there's no drama, there's no challenges. It's pretty much anything you ask this kid to do, they do it, and they do it creatively, and they do it well, and they bring other people along with them. And that's one of the things that's the hardest to get the kids to do. If I ask a kid to make something, one of the hardest things it is to do is to get the kid to go get a friend or get a buddy and have the buddy make it with them. And this person always does that. And this person really has never balked at anything that I've asked them to do. If I'm like, hey, could you do this? They just do it. And they do it with a smile on their face. And so we wanted to recognize this individual. And so we came up with the Core Values Award because they best exemplify the core values of our team. And that person is Alvin. Come on up. I hope I don't smell bad.
You don't smell bad.
Oh, good. Thank you. All right. So, Alvin, thank you very much for all of your hard work for our team. And Alvin made these boxes. Super cool. Okay, so next up, we have the Holly Lewis Excellence in Leadership Award. And we'd like to recognize a couple of our kids who have really stepped up into leadership roles this year. I have to say, I did not necessarily see them doing that. And they really have just stepped up and taken on a lot of extra duty and a lot of extra responsibilities. And so we're actually going to recognize two people, Ashton and Isaac. Erickson has taken over as one of our lead safety captain and put together an excellent binder, and I know that the team is going to be extra safe at our competition. And Isaac has really stepped up to be like team captain, kind of a leadership position on the team. I don't email the team things. I email Isaac, and Isaac emails the team things. Isaac's really taken care of a lot of extra stuff that I just haven't had the time to deal with, and it's been amazing having him on the team, and I'm really grateful that he was able to fill that role for us. So thank you to both of you for your hard work. All right, so the INT Community Service Award. So this is a little metal dog, and it doesn't look like much, but it means a lot. So someone in our community brought that to us because it was broken. And a huge part of what we do on this team is we learn how to do things so that we can use the skills that we gain to help our community. This individual learned how to weld and use his skills to help a member of our community. So, we'd like to recognize John Keel. All right, thank you, Jonathan. So, Jonathan is always going out of his way looking for ways to be helpful. Jonathan is actually leading up our Unified Robotics program that we are starting. And so we are going to be starting a program designed specifically towards helping people with special needs. And so thank you, Jonathan, for that. Okay, so our Woody Flowers nominee is not here. Is that me beeping? No. Okay, good. Our Whidbey Flowers nominee is not here. They have a whole bunch of other responsibilities in the community, including grandkids. But the kids are going to come up and read their Whidbey Flowers nomination.
Gary Thayer spreads excitement and energy to every person that shows up to the doors of our robotics room. Thayer demonstrates gracious professionalism in the FIRST values in everything he does. He does everything in his power to give each and every student the chance to learn and grow. Thayer aids everyone in becoming familiar with the various tools and processes inside our classroom. He not only helps with the robot-related topics, but he also helps to uplift our moods. Whenever we're frustrated, he uses his bright enthusiasm to teach us a lesson about life. He is a consistent motivator and guide in each of our lives and keeps us ready to take on the world. Thayer constantly includes everyone in each task we do. He regularly ensures that every person is participating and engaging in whichever project we happen to be doing. When he finds the team member without a job, he gives them a task to contribute to the team. In a time of unproductivity, he instructs the team to spend 5 minutes cleaning our workspace. He uses strategies like this to keep us productive and focused. Thayer also helps us learn to use the many tools that we have. Many devices like our laser cutter and our metal bender reoccur in our numerous activities, and Thayer ensures that everyone has a chance to discover how to use them. Thayer sometimes encounters challenges when he tries to help. Despite having trouble hearing students, which is compounded by everyone wearing masks for safety, he does his best to listen to everything that anyone says and understand their needs. When Thayer isn't teaching lessons, he He's always ready to help in any way possible. He's also willing to drive off to buy parts for a robot, and is always welcome to the idea of lending us a hand. When it comes to our various service projects, he willingly provides his truck for transportation of any resources that we need. The STEM field is a part of Thayer's everyday life. Thayer talks about his interest in chemistry and engineering with a passion, and shows such love through his music. He demonstrates his passion for teaching with songs he has memorized regarding science, and he uses these songs to teach us complex ideas. Thayer doesn't just spread his enthusiasm within our club, but also with many people as possible. At competitions, Thayer brings his love and excitement for robotics to everyone there through sports like announcing. Each and every one of us are proud to learn from and be students of Mr. Thayer. Thayer is not just a teacher, nor is he someone to be forgotten. He's a combination of a mentor, a figure to look up to, someone to learn from, and a guide that encourages us to have a positive mindset and attitude through all of life.
Won the Whidbey Finalist Award at the district championships. So we get to renominate him, and he goes right to competing at the world championship level. Now, this person is so awesome that he doesn't want us to recognize him here tonight. However, I put my foot down. So, William is going to read the essay for us.
Idoga has changed the lives of every member on our team. He does all that he can to help others, whether through teaching robotics and programming, or helping the community through special projects. Idoga is the reason for our team's focus on helping the community, and he has come up with the ideas for many of our service projects, such as our microhomes, prosthetics, haptic system, and our trip to Costa Rica, as well as the philosophy. I'm sorry, I can't read. Idoga is the reason for our team's focus on helping the community, and he has come up with the ideas for many of our community service projects, such as our microhomes, prosthetics, haptic systems, our trip to Costa Rica, and our workshop to teach our service philosophy to other teams. Once he gives us the idea, he lets the team members lead the project and only gives directions when needed. He encourages all the team members to participate and constantly pushes for the whole team to be involved with projects in places like Costa Rica and Houston, and is devastated when he can only send limited members. Special projects unite our team as well as all members have participated in at least one service project. When talking about Idoga, the 2016 Whidbey Flowers Award winner says that Idoga sees FIRST as a way to fix a lot of what is wrong, and the projects that Team 2980 does reflect that so well. Special projects would not be such a big part of our team without Idoga. Idoga utilizes his teaching experience as the main mentor for technical and mechanical aspects of our team. He is the CAD and design mentor and helps us maintain our robot during the season. He is responsible for almost all of our team's technical knowledge, but once we get to competition, Idoga chooses to be hands-off, spending his time volunteering. As said by Whidbey Flowers Award winner from 2016, he volunteers as often as he can and takes any job from crowd control to inspection, and tackles everything with equal passion, cheer, and enthusiasm. At a competition in 2019, this dedication won him the Volunteer of the Year award and kept him mentoring through 2 bouts of cancer, one during the 2020 COVID pandemic. He wants to create an environment conducive to our learning, so volunteering at our competitions allows us to grow and discover solutions while still having him nearby if we need him. A common culture aspect of our team that Edoga created is the act of getting coffee. This has been Edoga's method for maintaining team harmony for many years. Coffee is Edoga's code word for an individual conversation to discuss issues one-on-one. These can be conversations from minor problems or more serious issues like health and safety. These talks last anywhere from a few minutes to hours. Edoga will not leave coffee without ensuring that every student involved in the situation is satisfied with the solution reached. These coffee sessions are a problem-solving tool that Edoga has introduced and is now common for team members to ask any fellow team member to get coffee in order to discuss project problems and achieve a resolution. These talks are the reason a lot of team members have stayed on the team. During his time with FIRST, Edoga has proven with his spirit and dedication to exceptionally deserve this award. We are beyond grateful to have him as our mentor, leader, and friend.
Okay, so the part you guys have all been waiting for. Oh, there's more.
An important part of our team are our mentors and our coaches. We would like to take this time to recognize them and all the effort they put in with a small token, very small for all the time they put in. Mr. Thayer, Mrs. Carmen, and Mr. Edoga. You have Mrs. Carmen's. And there is a gift certificate for each of you to share with your better half. Thank you. And this is their
Okay, so now for the part you guys have all been waiting for.
Hi, I'm Jack.
And we're Team
2980, the Whidbey Island Wildcats.
If you're new to the channel, you build robots, do special projects,
And a whole lot of messing around.
Meet Pogbot. Or is it Jojo? I think it's Pogbot. No, Jojo. We don't really know. No, it's Jojo. Meet Jojo.
This robot features a Mark II swerve drive system by Swerve Drive Specialties with 8 Neo motors that allow the robot to move in any direction, with half the motors dedicated to moving the robot in that direction. Each individual wheel turns in the direction of travel, ensuring the robot is quick, nimble, and resistant to getting pushed around. 2 Neo motors running 5-to-1 versaplanetary gearboxes drive polyurethane belts at elevating balls to our scoring bucket. We do this in 2 segments, allowing us to expel cargo belonging to the opposing alliance while keeping cargo that belongs to us. While maintaining a low profile, our cargo deployment mechanism quickly and accurately deposits cargo in the lower port on the hub. 2 2-inch bore 8-inch stroke pistons create a theoretical lifting force of over 300 pounds.
You guys, if you want to come up and actually see the robot, they're going to unwrap it for you. And you guys can come up and see it, get close to it, and ask them all the questions you want. All right, pull it out. Okay, you guys bring the robot out so that everybody can see it. And you guys come on up, come ask questions. Team, get around your robot, answer all the questions that they have.
We renamed the robot out of kind of courtesy for JoJo, the little girl we're making the tricycle for.
Oh.
Yeah, it's kind of sweet. Oh, yeah. Other questions?
Can you tell us kind of how it works?
Okay. I'll do the other thing. So this goes down, and this all rotates to help move some balls up into the bucket, so then we can then tip it back. Then these hooks, if we want to do a low level climb, we can just lift, these pistons just lift up. But if we want to do a level 2 climb, we hit that on both sides, and then now we can reach the second level of the bar. Okay. I am. I don't deny it. That's just generally how it works.
Should we do a nice spin for everyone to see?
Sure, why not? Ooh, donuts. The robot could do this on its own too. It'd go in a nice little circle.
Yeah.
Probably a lot smaller.
Yeah, but then we'd have to boot up the computer.
No,
and get the program.
I know. I didn't say we were going to do it. I said it could do.
If we wanted to.
Because then we risk breaking it.
Yeah, one, we risk breaking it, and two, we're too lazy to get the computer out.
Yeah. Not too worried. But there's still people. Okay. Any more questions?
Okay, I have another one.
Okay.
Before competition, do you guys get to know what you're going to be doing with the robot?
We do know what we're going to be doing. Yeah. So, can we
show
show
the
the
game
game video? You know what? We're just going to do that anyways. I don't care. Hey, hey Wilson, why don't you come up here and wave to the peoples?
Wilson, come on.
Come on, Wilson.
Come on, Wilson.
Wilson's our wildcat. Come on, Wilson. 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 High five. Sorry. His eyes are way down there. You can't see my hand. Yeah, Wilson's here. Alright, well, wave hi to them, Wilson. And now the video. Let's go.
This video is going to explain what the game actually is.
Welcome to the 2022 FIRST Robotics competition. And this year's game, Rapid React, presented by the Boeing Company. 2 alliances of 3 teams each compete to score their cargo balls into the lower hub and the upper hub. They earn additional points if the robots traverse the rungs of their hangar. Robots start each match on one of their tarmacs and may be preloaded with 1 cargo each. During the first 15 seconds, robots are autonomous, without guidance from drivers. They leave their tarmac, score preloaded cargo, and collect and score additional cargo. During the remaining 2 minutes and 15 seconds, drivers control their robots. They continue to gather up 2 cargo at a time and score cargo in the lower and upper hubs. Cargo scored into either hub count towards the cargo bonus. Launch pads protect robots from contact by opponent robots. Robots may use either terminal, where their human players assist the robots with acquiring cargo. As time runs out, robots race to their hangar and traverse as many rungs as possible. The higher a robot gets, the more points it earns. An alliance that reaches a hangar point threshold is rewarded with the ranking point. The alliance that earns the most points wins the match.
So that's the game.
I have one thing for you guys. So we have these beautiful iPhone pads. These are courtesy of Jim Wright, Team Stealth. I don't know the number. Didn't have enough time to find it. But it's Jim Wright from Team Stealth. He gave us these wonderful eyes to do all this cool blinking and they move around. Later versions will do things when the robot moves in certain directions. So that's really cool. And we thank him for sending us those. Yeah. Okay, now back to questions. Anybody have any questions? What's up, Elgin? What's your question?
My question was,
Okay, maybe Elgin has a question, but we're going to give her a minute.
yeah, I think I need a minute real quick.
Okay, any questions? Yes, Anthony.
How hard was Swerve Drive to program?
Branson, Isaac,
That's a you question.
So we spent a lot of time trying to wrap our head around the program, and then like 4 weeks into trying to figure this out, one of our big issues that we were completely overlooking was that we were missing a single decimal point in the entire program, so all the wheels were turning off by like an 18th of a degree or something. So once we figured out the decimal point, everything worked pretty smoothly.
Yes, now Elgin. Thank you, Anthony, for the question. Elgin, what's your question?
What was the difference between a swerve drive and any other type of drivetrain?
Okay, I'll do this one. Swerve Drive can move in any direction. It's really good, it's really fast, compared to what we've been using, which is tank drive, or arcade drive, sorry. Arcade drive is like a tank. One side moves independently from the other, but there's all sorts of math, so you don't quite control it like a tank. You can control it with one single joystick.
Whereas this one,
Yes.
you can move in any direction and rotate while moving in that direction, and it's really cool.
Kimber first.
What was the process for building the ball elevator?
Okay, Wheels.
So our first version of our ball elevator didn't have all these holes in the middle. But then we weighed the robot and we were overweight by like 5 pounds, I want to say. No, 5. And so we cut out these holes to make the robot lighter. but then the ball elevator was very flimsy. So we added a couple of supports on the top to keep it from wiggling as much. And then we've run into issues with some of the belts coming off of where they're supposed to be. We're still working on a more permanent solution for that. Yeah.
Didn't include the part about
Algin.
Why are the hooks built like that?
The what?
The
Well,
hooks built like
hooks are
that.
built like this so that we can do both a level 1 climb like in its current position, and then we can hit the low bar and do a level 2 climb in that position.
Wilson.
Oh, the blinky? The orange light? No, the frame.
Framing? What about the framing?
Okay, the framing is built out of 1/16 wall aluminum, which means it's really thin, but it's still quite sturdy. So it doesn't weigh a lot, even though we were running into weight issues. That's why we didn't drill holes in the frame, because it doesn't actually weigh that much. There's parts of it that we had to reinforce later on from what we were initially planning. But everything mounts to the frame, so it needs to be really strong, and it needs to not move anywhere. Anything else, Will?
If anybody else has any questions?
No, all about the frame.
Oh, not really.
Wait, there's someone who has a question right
Yes.
here.
Yes.
You said that you run into a lot of issues with the weight of the robot. How much does it currently weigh?
Currently it weighs 125, 20 pounds, 120.
122.
Yeah,
Okay.
somewhere around there.
Yeah, and our weight limit is 125 pounds.
Wow.
So
It's
sneaking in there.
Yeah, to help with weight reduction, we cut these big holes inside of the intakes to help with weight reduction.
We also removed our dump bucket as well.
They can't see that room.
We also removed one air tank. We were going to have 4, but we went with 3 air tanks instead.
Yeah. So let them see the eyes.
Yeah, these beautiful eyes, courtesy of Jim Wright. Great.
Oh.
Okay. Okay. Okay, any more questions? There has to be.
Did you guys make all the parts in your shop, or did you have to outsource parts?
No parts were outsourced.
Except for the swerve modules.
Well, yeah,
the
those
swerve
were bought
modules-
as a kit. Obviously,
Yeah.
we didn't make things like pistons and motors, but we
But-
bought a lot of this out of the kit.
All of the polycarb bits, polycarbonate bits, the aluminum bits,
All the plugs,
and yeah, and we also 3D printed all of these
rollers.
rollers to help keep the the belts in place.
And all of like the stock pieces we cut down, everything like
Yeah,
that.
all fabricated in our shop here at the high school.
The electronics, do they come as a kit, or did you
The
have
electronics we buy individually.
Yeah.
Well, some of them come in the kit parts.
Yeah, some of them come with like the original starting kit, I think. Or do they come every?
Yeah.
Yeah.
The original starting kit. So like our radio here, which helps the robot communicate with our driver station, which is
that
inside the
something
cart.
that's supplied by the competition?
Yeah, the radio, yes.
Okay.
And
That's
the
what-
Robo Rio.
Everybody uses that to build their.
Yeah. Algin?
What is this part for?
This part?
Yeah.
That part allows the ball. Yeah.
This part here?
Allows the cargo to come out and into the dump bucket, because we were having issues
With
where
the ball falling into the middle of the dump bucket so that we could only fit one in there instead of two. Because we want to be able to fit two in here because that allows us to score the most amount of points at one given time.
Next question. question, and then I'll show you guys something. One more question, and then I'll show you guys how we control the robot. Or Isaac will show you guys how we control the robot. Yeah. So, if there's no more questions right now, then we'll show you our driver station.
So this is our driver station. We have two drivers, one that stands over here and operates the drivetrain and drives the robot around, and another that pushes all these buttons and activates the intake and the ball elevator and the dump bucket and all of the other mechanical things.
Yeah, you can push.
Is that like those switches, like a USB?
Yeah, we connect this to a Windows laptop that connects wirelessly to the robot.
Yep.
Logic.
This whole thing shows up as a USB joystick in Windows.
So it has all the logic to show up as a USB joystick.
That's awesome. Do they light up, or they all like?
They have
They have the LEDs in to light up, but we've never wired that part, so they stay off.
We should do that. We should wire
I work with EG, and I actually have some drivers for that, so they light up. It's pretty cool.
Yeah.
You should tell them on off.
But that's just an idea.
They're all.
I haven't seen EGs. I was like,
Putting it back.
Yeah, let's put it back. What else? Anything from my team members? You guys want to talk about anything specifically that you maybe worked on a lot? Branson, why don't you come talk about the code?
You want me to talk about the code?
Yeah, I feel like we have some. Yes.
What do you want me to say about the code?
These are Mechanism wheels, and they help control the cargo so that it actually goes into the intake and gets sucked up in. So when we drive, if a ball is sitting here and we drive it and start rotating the intake, these rollers here will push the ball into our actual intake instead of having it spew in a different direction.
Okay, Branson's going to talk about the code.
It's my turn? Okay, well, I'll talk about, we already talked about swerve code, so we're talking about autonomous. So normally when we program autonomous in all past years and everything, what we've done is we've just had like a set of commands, one after another. Drive forward for 10 seconds. And then you think you're where you want to be, but you're not 100% sure, because all you know is you went 10 seconds in some direction. But this year, with swerve, it's actually smart enough to know where it's at on the field. It knows where it started. It knows it's gone 10 feet in this direction, so it must be 10 feet offset. And if it gets off of that value somehow, like it bumps into something or it gets caught on something, it will continue to move towards that position until it actually gets there, which makes for much more reliable autonomous programs and way easier to make after the fact, for sure.
Okay. Thank you, Branson. Okay, does anybody have any questions before I find something else to talk about?
Is that
Yes.
Is the autonomous coding more difficult than the coding you guys were using before?
So what?
Is
that's
the
more of an Isaac code.
coding that you're using now more difficult than it was before?
So in order to make the system that it goes off of, we had to put in a little bit of extra effort. But once it's in place, now like programming autonomous is a breeze. I just say like, I want you to go to a position that's 10 feet to the left and 2 feet forward. Well, actually it's in meters because meters are cool. And so I just say, I want you to go to this point, and it'll track a path and it'll go there. Instead of me having to say, go this way for so many seconds, or read the encoder values and do weird things, I just say, go there, and it doesn't.
Algin.
I have 2 questions. So, first, is that light just there for because you wanted it to be there, or does it actually have a purpose?
So this light and the light over here, those are Mr. Blinky. Mr. Blinky, all it does is it if it's lit up, that means there's power going to the robot and the robot is turned on. And if it's blinking, that means that the laptop has enabled the program and we are able to move the robot and control it.
Okay. Also, how long did it take you to program everything? And did you start from scratch?
So yeah, we basically start from scratch. We've got our code from previous years to reference, other people's code, definitely helpful, but it's basically from scratch. And it's taken us the entire time, all of the time, because it took forever.
What's up, Courtney? How excited is everyone for competition this weekend? Woo!
Super excited! Competition, that's my favorite. Anthony.
What was the hardest part
Probably the swerve drive, because that did not start this season. We had done a lot of research and we spent time developing or learning how the code works, learning how to put it together a couple seasons ago before COVID. So that's been going on for probably 2-3 years now.
So, if we're going to forget about the storage drive for a moment, the most painful part to actually make is probably the ball elevator. The reason why, that went through so many different revisions. It was too tall, too heavy, so you had to remake the entire thing. It was stressful. And on top of that, putting in the belts is no easy task because you have to, one, make the belts, make sure they're all tight enough, and then assembling it is a lot of pain, is basically painful because of the amount of forces that are put into it. So, yes.
That is the most, and the fact that we took it in and out, in and out, in and out, in and out, in and out.
Is that it for that one? For that round of questions?
Anthony.
Yeah.
What do you like about this robot more than in past years?
I feel like everyone on the team should kind of go through that question individually. So my favorite part about this year's robot compared to a couple years ago is now we use swerve drive, which is way more efficient. It can go in almost every direction. It's just really awesome, not that cheap, and it's amazing.
And the only direction that it can't go in is up.
Yeah.
Or down.
No, it can definitely go down.
It's called breaking it. Yeah. But we don't want to do that. Breaking things is bad.
At this point, these are pretty priceless because they're old modules.
Yeah, they're old modules.
But I think a new one runs me about
like
4,500 bucks?
Yeah, like 40, yeah.
No,
for all of them.
For all of them, it's like $2,000. For each, it's 450 bucks around, somewhere around there.
Yeah, it's like
the $400 range.
If you want to get everything for Mark IV Swerve, I think it'll run you like $6,000.
Yeah, with a couple spares.
Yeah. $6,000.
$6,000. That's
for everything for Mark IV.
That's for like
if you want everything and you want spares.
Yeah. How many? I don't think that's the right number, Will.
My dad and I did the math. It's like $6,000.
Jesus.
Yeah.
Is that to yeah, no, that's not to upgrade. That's just to
that's just to get Mark IV.
Yeah. So it's about $6,000. It's not cheap.
And that's not even including the framing that that's getting all 4 modules. That doesn't include the framing.
The framing we get free with registration costs.
Yeah, because
we're not going to go into registration costs.
Yeah. We're not going to go into the 40 free rolls of duct tape.
Okay, it wasn't that many. It was like 20.
It was 40 rolls of duct tape, Branson.
40?
Yes.
It absolutely was 40 rolls.
And a roll of flex tape.
And,
We should have gotten more.
We could only get one.
My personal favorite part of the robot is the climbing mechanism, because I was spending a long time trying to think of a way to do something like this during Design Week, which is the week that before we present. It's the week between when we see the reveal video And when we present ideas to the community on how how each kind of group in the robotics team presents their ideas on what they want to build to the community, and then the community takes parts that they like from each robot and throws them into the robot that we make. I was trying to figure out a way to do something similar to this, and I couldn't, and I just think this is such a creative way to do this, and I just really like it.
So is this going to lift itself off the ground and climb?
Yes. So each climbing mechanism is attached to a piston that will latch onto a bar, and then when it's lowered, it will pull the entire robot off the ground.
Okay.
Algin.
So with that type of climbing mechanism, are you still able to go to all 4 bars, or?
No, we are only able to go to the first 2 bars. So if we raise the climbers up like this, as is, we go to a first level climb here, but if we flip them up here, we can go up to a 2nd level climb up there.
Anthony, what's your question?
What do you guys plan to do with the robot after this season?
Yeah, we're gonna murder it when the next FRC season.
Yeah, we're gonna salvage it for parts.
Let's be honest, that's where this robot's ultimately gonna end up. Another robot.
Yeah, we're just gonna salvage it for parts. Because inevitably we're gonna need something like these pistons.
And how about like the swerve module?
Or the swerve module.
Yeah,
stuff like that. And we're just gonna be lazy and not want to buy new ones.
Or we can use that as an excuse to get new ones.
Yeah.
I mean,
yes.
That would be nice. So if we already have it and another robot, just take it off that robot and use it for the new one.
Aristine's gonna say something about the ball elevator.
One cool thing about the ball elevator is that basically it's 2 different parts. So if we have a ball up here that's our line's color, but we accidentally took one that's not, we can keep this one up here while dispelling the one that's from down here, because these systems are run by 2 separate motors. So it's a really cool way to make sure that we're going to be playing as fast as possible.
Okay. Now Isaac here is gonna introduce our teams and like our sub teams.
Our sub teams for competition.
For competition, yeah.
Wait, does Anthony have a question?
What's your cycle time for getting a ball and putting it in the?
I mean,
our fastest cycle time right now. Let me see.
I think
13.2 seconds.
I thought there was more.
Was the average cycle
Was
time
that
between?
for 2 balls or 1 ball?
Our
That's for 2
goal
balls.
Is 10 seconds.
Yeah, our goal is
and that's the average.
around 10 seconds.
And that's the average, right, Will?
Yeah, that's the average cycle time across a 2-minute and 15-second window, which is the length that we will be driving that is not in the autonomous period.
And the cycle is how long it takes to
intake.
Go from the hub, intake 2 balls, come back and dump them off.
Yep.
All right. So
I want to introduce the.
I guess the first sub team would be the drive team. So we have Will Harmon as the drive code.
I am the drive couch.
We have Jack as technician. We have human player. Connor as human player.
Anthony, get up here. Anthony.
The guy trying to hide. Anthony is the co-driver, and I am the main driver.
So why don't we go down the line and explain what each of our rules on drive team is?
Okay.
So
I drive with the joystick. He pushes the button.
I lift the robot on and off the field. I do last minute repairs, and I'm the main person for if we have back-to-back matches.
I'm the human player, so I interact with the balls on the field. I make sure to get them into the robot if our intake stops working, and occasionally I get to take shots into the hub.
But you're not actually on the field.
I'm not on the field.
Yeah. I'm the drive coach or drive couch. I'm not sure anymore. And my job is to talk with the other drive coaches on our alliance and formulate a strategy for what each team and robot is going to do for a certain match and when they're going to do it.
All right. Our next sub-team is going to be the pit, and we've got Mason, Kimber, Courtney as the pit boss, Garrison is safety captain and Gideon. They're all on the pit.
Courtney, what do we do? Oh, so basically, our job on the pit is to repair the robot after matches. We do things like repair the battery, or not repair the battery, replace the battery. And then the drive team will give us things we need to do in order to fix it, any problems that went wrong with the robot during the match. And then, yeah, we just kind of fix that right before the next match. So.
And I make sure nobody gets hurt while doing so.
Yeah. Should we introduce ourselves?
I'm Kimber.
Oh, I'm Courtney.
I'm Aristine.
I'm Mason.
Our next sub-team is the Scouts. Yep. So we have Natalie as Scout Captain, and then our Scouts, Elgin and Danny and
So you're in here as well. You can be team.
So would you like to explain what the Scouts do?
So, Scouts, we document the other teams, and we also figure out if they taxi, which is when they go out of their little zone. We also figure out how many cargo they put into which hub, and we all put this into a spreadsheet, and then we use this information to choose our partner for the final matches.
Yep.
Let's go.
And then, let's see. Chairman's team? Yeah. Next up is Chairman's team. We have Allison, Connor, and Aristine. They presented earlier. They presented the Chairman's presentation to the judges.
It's a lot of fun. Chairman's is kind of like a award that kind of is near and dear to 2980 because we like to do a lot for our community when it comes to our community, and we like to inspire others to do the same. So.
And we also like to continue to have fun with the robot, and this is one of the ways we get to continue doing that. Is that all the teams?
Almost. And we have Central Zone, and then Team Spirit, and where's Wilson?
What? Oh, Wilson.
Wilson.
Wilson!
Wilson! Come here, Wilson! And okay. Here we have Wilson the Wildcat and Aiden. I'm not going to even pretend to pronounce your last name. But Aiden and Wilson, and somewhere's John Shields. And these are our spirit team. They're in charge of making our team, they're basically the cheerleaders, let's face it. And the mascot, except for they can't all do cool flips and things.
Yeah, you can't do cartwheels. I wouldn't recommend it.
Don't do cartwheels. Let's not try that one. Yes. Or move back. So, do you guys want to do a cheer for us real quick?
Okay. We all gonna start?
29! 29! 29! Okay, thank you, Team Spirit. We gotta work.